Okay, so the next test that we're going to look at is called the root test. The root test is pretty similar to the ratio test and how it works. So let's look at the definitions for the root test. So let there be some series a sub n, be any series, and suppose that the limit as n goes to infinity of the nth root of the absolute value of the nth term goes to some number, which again we're going to call rho. Then there's going to be three possible outcomes, and they're the same outcomes from the ratio test. The series converges absolutely. If that rho value is less than 1, the series is going to diverge if that rho value is greater than 1, and then the test is inconclusive if that rho value is equal to 1. Okay, and then let's just look at some examples. So let's look at the series n equals 1 to infinity of n squared divided by 2 to the n. Okay, does this converge or diverge? All right, so almost always, if you could use the ratio test, you could also use the root test and vice versa. But a lot of times the root test is easier for certain situations. Whenever you have an n as an exponent, usually the root test is easier. Also, if you just have one term or one fraction with single terms in it, it's easier as well. Okay, so let's just do it. If we're trying to figure out if this converges or diverges by the root test, we have to look at this limit. So let me just copy this down. All right, so it's the limit as n goes to infinity of the nth root of the absolute value of the nth term. So for our instance, it's going to be the limit of the nth root of the absolute value of n squared over 2 to the n, just whatever the sequence is as is with our n's. Okay, first things first is that because my n is going from 1 to infinity, everything on the inside is already positive, so we can ignore the absolute value. The next part is that I have the nth root of a fraction, which means that I can take the nth root of the numerator and the nth root of the denominator separately. So let's look at the nth root of n squared divided by the nth root of 2 to the n. Like this. Oh, geez, not like that. Just hold on a second. I'll make it work. Don't worry, kids. There we go. That looks better. All right, so the limit of the numerator, the nth root of n squared, divided by the denominator, the nth root of 2 to the n. Let's worry about that numerator first. So what we're going to do for that numerator, why does it always do that? Is we're going to interchange the 2 and the root. Remember that you're allowed to do that because that's all the nth root is. It's an exponent of a fraction 1 over n. So we're going to interchange that and rewrite this as the nth root of n and then that to the second power. Like that. So basically just bringing this exponent of 2 outside. In the denominator, we have the nth root of 2 to the n, and I hope it's obvious that those two things just cancel out and we just get 2. All right, so now we have to talk about what that numerator does. And this is something that you should remember back from section 1. In section 1, we looked at some common sequences. This is one of my common sequences, the nth root of n. So if you just go back in your notes for that, the nth root of n just goes to 1. 1 squared is 1, so I get the limit of 1/2. Ah, jeez. and the limit of 1/2 definitely just goes to 1/2. Then that means that's going to be my row. So that's the first part of my root test. The row came out to be less than 1, and that means that my series converges absolutely. Which, again, I know that doesn't make sense to say it converges absolutely because these are already all positive terms, but we still want to write that just because it's a more powerful statement. Let's look at one more example. Let's do this one. So this will be the series n equals 1 to infinity again. This time 2 to the n over n cubed. Same question. Does this converge or diverge? Okay, we're going to use the root test again because we have this n power and just a single fraction with just no adding and subtracting anywhere. So we have to again look at that limit. It's going to be the limit of the nth root of the absolute value of the nth term. So I'm just going to plug it in as is. Okay. Same stuff is going to go on here. The inside of the absolute value is always positive, so we can ignore the absolute value, and then we're going to take the nth root of the top and the bottom separately. If I take the nth root of that numerator, I'm just going to get 2. If I take the nth root of the denominator, it's the nth root of n cubed, which is going to be the nth root of n all cubed, which is going to be 1 cubed, which is just 1. So this time I get the limit is 2. Don't forget that that means that that's my row. This time it's bigger than 1, so therefore the series diverges. Okay, so the ratio test and the root test are by far the most powerful tests that we have to see if a series converges or diverges. This is usually what you guys are going to be using to test for convergence. Use the ratio test whenever you have factorials or if you have addition and subtraction anywhere. Use the root test anytime you have a power of n anywhere. Okay, cool.